I am Balaji Rao. Welcome to BR Max class. In this class, we will learn definition of logarithm with examples. It comes to the definition of logarithm, it's not very easy definition. It takes some time to understand the definition. Please watch this video till the end to understand complete definition of logarithm. First, we will see what is the definition of logarithm. You observe here, a comma b are two positive real numbers and a not equal to 1 such that a power x equal to b. Here I considered a and b are two positive real numbers. We are taking a and b are two positive real numbers and a not equal to 1 such that a power x equal to b. For example, you see here 3 square. 3 square equal to 9. You see here this is a, this is b. These two are positive real numbers and this is not equal to 1. Try to understand. What I am trying to say, if you are able to find an equation of the form a power x equal to b, here a and b are positive real numbers and a not equal to 1. If you are able to find such expression, then only logarithm defined. You observe here, in this a power x equal to b, x is called logarithm of b to the base a. See, whatever I written here, the full thing I'll write in a single line. If you are able to find such thing, a power x equal to b, then x is called, this x is called, what x is called? Logarithm of b. Logarithm. See, I'll just simply write log. Log is the abbreviation of logarithm. Logarithm of b. Simply I'll write log b to the base a. And here very important point is, it is if and only if condition. Whenever you see a power x equal to b, then you can write x equal to log b base a. At the same time, whenever you see x equal to log b base a, it can be written as a power x equal to b. You try to understand, this is if and only if condition. Whenever you see a power x equal to b, you can write x equal to log b base a. At the same time, whenever you see x equal to log b base a, we can write a power x equal to b. So here you see, if you are able to find 3 square equal to 9, as per the definition of logarithm, what you can write? What is 2? What is 2? 2 is called logarithm of 9 base 3. Okay, try to understand here. Logarithm of 9 base 3 is what? 2 is called logarithm of 9 base 3. Correct? From the definition, if you are able to identify 4 cube equal to 64, from this expression, you write the logarithmic form from the definition. 3 is called, 3 is what? 3 is logarithm of 64 base 4. I hope you are understanding. Now you see 5 square equal to 25. 2 is called logarithm of 25 base 5. Yes. Now you see here, this is a power x equal to b. As per the definition, what it can be written as? It can be written as x equal to log b base a. I hope you are understanding. What we will discuss now, that is more important. These things we use while solving the problems. For example, if you see an expression of this form, log b base c equal to x. You observe here, if you see x equal to log b base a, it can be written in the form of a power x equal to b, na exponent form. This is exponent form. Here, log b base c equal to x, what it can be written as? As per the definition, it can be written as, you observe here, you observe this base, a power x equal to b. Here, what it can be written as? It can be written as c power x equal to b. Try to understand. It's simple thing. You please observe this. Log 32 base 2 is 5. Logarithm of 32 base 2 is 5. How you can write this in the form of a power x equal to b? How you can write this in the form of a power x equal to b? You just take this base power this number, 2 power 5 equal to 32. I hope you are understanding. This is the definition of logarithm. What is the definition of logarithm? A and b are two positive real numbers and a not equal to 1 such that a power x equal to b. Then x is called logarithm of b to the base a. whatever the meaning is there, that full meaning is given in this one line. What is that? If you are able to find a power x equal to b, then this x is called logarithm of b to the base a. Here important point, a and b are positive real numbers and a not equal to 1. Why a not equal to 1? That we'll understand in the coming examples. Okay, so what we learn, when you see a power x equal to b, then x is called logarithm of b to the base a. See, after the examples you will get more clarity about this definition of logarithm. In case if you want to find logarithm of 25 base 5, what is its value? You want to find this logarithm of 25 base 5 value, you want to calculate. How you will calculate? See here, I'll take this value as x. Solution. First, I'll take logarithm of 25 base 5. Its value is x. That means I need to calculate x value. Please observe here, when you see this type of expression x equal to log b base a, how you will write this in exponent form? It can be written as a power x equal to b. Try to understand, a power x equal to b. Here this can be written as per the definition, this can be written as, yes, you take this 5 in the base, 5 power x, 5 power x equal to 25. How can you write like this? As per the definition, just we learn this definition. Okay, so 5 power x equal to 25. Here 5 power x equal to, this 25 can be written as 5 square, correct? So here as bases are equal, power should be equal. So what is x here? X is 2. Okay, what is x? You see this, what is x? X is log 25 base 5. So log 25 base 5 is equal to 2. Okay, now we'll try to understand this with one more example. Suppose if you want to calculate logarithm of 64 base 4 value, how you will calculate? First, I'll consider this as x. Logarithm of 64 base 4, I'll consider this as x. As per the definition, when you see the expression of the form x equal to log b base a, it can be written as a power x equal to b. So how we can write this as? It is important. You can write this as, you take this base 4 power x. 4 power x equal to 64. Please try to understand. Okay, 4 power x equal to 64. 64 is nothing but 4 cube, correct? 64, 4 into 4, 16. 16 4s are 64. Okay, as bases are equal, power should be equal. So what is x here? X is 3. So what is x? Actually, we consider this expression as x. Okay, so logarithm of 64 base 4 is 3. You observe this base, this is 5. What answer you got here? You got 2 here. What expression is there here? Here 25 is there. You please observe here, 5 power, by writing what number you will get 25, that is the answer. Please catch this point. Similarly, no need to go through all this procedure. Logarithm of 64 base 4, you observe here, 4 power, what number will gives you 64, 4 power, that number is the answer. See, we know that 4 cube is 64. If you are able to identify 4 power what number is 64, directly you can write its answer. Okay, for example, you see this example number 3. Logarithm of 32 base 2. What is its value? If you are able to identify 2 power what number will be 32, that is the answer. 2 power what number is 32? 2 power 5 is 32. So its answer is 5. You can write directly like this. In case if you don't know, then as usual procedure. What is that as usual procedure? First I'll take log 32 base 2 as x. As per this definition, I can write a power x equal to b. What I can write here? I can write 2 power x. 2 power x. This is important. You need to understand this. 2 power x equal to 32. 2 power x equal to 32. 32 can be written as 2 power 5. As bases are equal, power should be equal. X equal to 5. What is x? We consider log 32 base 2 as x. So here this is log 32 base 2 equal to 5. You please observe this example. We need to find log 5 base 25 value. What point I discussed, if you are able to identify 25 power what number will gives you 5, that is the answer. 25 power what number will gives you 5, that is the answer. If you identified it directly, write the answer directly. Otherwise, you just go through the procedure. What is the procedure? You take log 5 base 25 as x. Okay, so you need to find this value now. So here this can be written as, you take this 25 power x can be written as 5. How you can write like this? As per the definition. Okay, so here 25 can be written as 5 square whole power x equal to 5. Okay, here it is of the form a power m whole power n, that is nothing but a power mn. So 5 power 2 into x is 2x equal to 5 can be written as 5 power 1. You observe here, as bases are equal, power should be equal. So 2x equal to 1. What is x from this? X is 1 by 2. What is x? We considered log 5 base 25 as x. So what is x here? X is log 5 base 25. So you got the value of log 5 base 25. What is its value? Its value is 1 by 2. Once again I am saying here, 25 power 1 by 2 will gives you 5. If you want, you can check. 25 power 1 by 2. Check it. What is 25 power 1 by 2? 25 can be written as 5 square. 5 square whole power 1 by 2. Here 2 will get cancelled. What you will get? Its answer is 5. So if you identify in the beginning itself 25 power 1 by 2, that means root 25. Root 25 is 5. Directly you can write its answer. No need of all this procedure. In case if you are unable to find it directly, then follow this procedure. I hope you understand. What is logarithm? Logarithm is an exponent. You see here, exponent is the answer. This is the base. This is the exponent. Exponent is the answer. Remember this. You see this example, log 1 base 10 is what? If you are able to identify 10 power what number will gives you 1, that is the answer. If you are not able to identify, you follow the regular procedure. What is that regular procedure? I'll consider log 1 base 10 as x. As per this definition, this can be written as, yes, this can be written as 10 power x equal to 1. Okay, 10 power x. Here to find the value of x, this 1 can be written as 10 power 0. 10 power 0 value is 1. We know that. Correct or not? Yes. So as bases are equal, power should be equal. What is x value here? X value is 0. What is x? I considered log 1 base 10 as x. So right here, log 1 base 10 is 0. In the beginning only, if you identified that 10 power 0 is 1, directly you can write its answer 0. Please get this point. Logarithm is an exponent. Remember this point. Logarithm is an exponent. Now last two examples which will gives you more clarity about this logarithm definition. Okay. You see logarithm of minus 2 base 3 value. You just start doing, you try to get this answer. We will see what you will get in general procedure. First I will take logarithm of minus 2 base 3 equal to x. As per the definitions, this can be written as 3 power x equal to minus 2. Now you identify 3 power what number will gives you minus 2. 3 power what number will gives you minus 2. You see 3 power any number is always positive. Suppose 3 power minus 2 I written. In place of x, if I write in minus 2, what is this? This is nothing but 1 by 3 square. This is nothing but 1 by 9. This is positive only now. So 3 power any number you write, it is always positive. If you take x is 0, 3 power 0 value is what? 1. Try to understand. What I am asking you, you find some x value such that 3 power that number is negative. You won't get. I hope you are understanding. You cannot find x such that 3 power x is negative. So what happening here? It is not defined. We cannot find this value. That means what I am trying to say here, logarithm of minus 2 base 3 value is what? What is its value? Its value is not defined. Why it is not defined? Because logarithm is defined for positive real numbers only. Log is defined only for positive real numbers. Logarithm is defined only for positive real numbers. In this definition, a and b are positive real numbers and a is not equal to 1. You keep this point also in your mind. This base cannot be equal to 1. Now last example, log 4 base 1. What is its value? You observe here, we know that logarithm is defined for positive real numbers and this base value cannot be equal to 1. Here base value 1 is there. This is not defined. In case if you don't know all those things, try to do this in regular method. What is that regular method? I'll consider log 4 base 1 value is x. As per the definition, this can be written as 1 power x equal to 4. This can be written as 1 power x equal to 4. You identify the x value such that 1 power x is equal to 4. You identify x value. 1 power what number is 4? 1 power 4 is what? 1 power 4 is 1 only. 1 power 3 is 1 only. 1 power what number will gives you 4? You cannot find x value such that 1 power x is 4. Are you understanding? That's why in the definition itself they clearly mention that if a and b are positive real numbers and a is not equal to 1, then only logarithm is defined. So what you will say here, what is the value of log 4 base 1? What is its value? In the base 1 is there. That's why this is not defined. Nobody knows its value. It is not defined. Why it is not defined? Because base cannot be equal to 1. As per the definition, base cannot be equal to 1. I hope you got clarity in the definition of logarithm. In the next class, we will learn the properties of logarithmic function. Properties of logarithms with their proofs. Total 9 properties are there. And this is the first property. What is the first property? Log 1 base a is 0. Log 1 base a value is 0. Here what is a? A is a positive real number and a value not equal to 1. Okay, so this result holds good when a is greater than 0 and a not equal to 1. So we will see the proof of this result. From law of indices, we know this formula. What is that formula? A power 0 value is 1. See, we learned this in laws of indices. A power 0 value is 1 when a is not equal to 0. What is 0 power 0? 0 power 0 is not defined. So here a power 0, 2 power 0, 1, 3 power 0, 1, 4 power 0, 1, 0 power 0, it is not defined. So we know this formula, a power 0 is 1 when a is not equal to 0. Here we know that a is greater than 0. That means a is not equal to 0. So we know this result from laws of indices. What is that result? A power 0 equal to 1. From the definition of logarithm, what we learned? In last class, we learned that whenever you see an expression of the form a power x equal to b, then x is called, x can be written as log b base a. X can be written as log b base a. This is what we learned in last class. So here you observe, you compare this one and this one, write it in logarithm form. Here it is in the form of a power x equal to b. So 0 is called, what is 0 is called? 0 is called logarithm of 1 to the base a. Simply we write 0 equal to log 1 base a. I hope you got the point. We proved the result. What is the result? Therefore, we proved that log 1 base a is 0. From now onwards, we use this property as formula. For example, suppose log 1 base 2 is there. What is the value of log 1 base 2? As per this property, its value will be 0. Directly you can write. From now onwards, we use this property as formula. And you see, log 1 base 5. What is log 1 base 5 value? Log 1 base 5 value is 0. Log 1 base 100. What is its value? Its value is also 0. So what you learn here, log 1 base a is 0. Similarly, you see here log 1 base 1. What is its value? Its value is not defined. Please try to understand. Not defined, because this formula works only when this a is greater than 0 and a not equal to 1. Here what happened here? Here base equal to 1. Since why it is not defined? Since a is equal to 1. So here a cannot be equal to 1. As a equal to 1, log 1 base 1 value is not defined. I hope you are understanding. You see this second property. What is the second property? Log a base a value is 1. Log a base a value is 1. Here what is a? A is a positive real number, and as a is in this base, a cannot be equal to 1. So I'll do the proof of this result. You know this result. What is a power 1? A power 1 is nothing but a only. It is very easy. 2 power 1 is 2. 3 power 1 is 3. Like that, a power 1 is a. So from the definition of logarithm, what we learned? We learned that if you see a power x equal to b, then x can be written as log b base a. Correct? So here a power 1 equal to a. You compare this one with this a power x equal to b. Then what it can be written as? It can be written as 1 equal to log a base a. I hope you are understanding. We got the result. What is the result here? Therefore, log a base a equal to 1. From now onwards, we use this property as a formula. For example, you see log 2 base 2. What is the value of log 2 base 2? We know that log a base a value is 1. So what is log 2 base 2? Log 2 base 2 is 1. Log 3 base 3. What is log 3 base 3 value? It is 1. Log 100 base 100. What is its value? We know that log a base a value is 1. And you remember that here a must be positive real number and a not equal to 1. For example, it is like this. Log 1 base 1. What is its value? Can we write it as 1? No. Here base value is 1. But as per this formula, base value cannot be equal to 1. What is the value of log 1 base 1? The value of log 1 base 1 is not defined. Third property. Let m comma n are two positive real numbers. What are m and n? They are two positive real numbers. And what about a? A is positive real number and a not equal to 1. In such case, this property works good. Log mn base a can be written as log m base a plus log n base a. We will prove this property now. To prove this property, first I'll consider this log m base a as x. Log m base a. You consider this log m base a as x. And you consider this log n base a as y. How we write this in exponent form? You observe here how we write this in exponent form. Base, what is base here? A power x equal to b. Like that, how we can write this into exponent form? Yes, how we write? Yes, you take this base, a power x equal to m. Good. Similarly, how we can write this into exponent form? A power y equal to n. Okay, I want to prove this result. To prove this result, I'll just multiply these two things like a power x into a power y. What is a power x? A power x is m into what is a power y? A power y is n. As we know here, bases are equal, power should be equated. What is a power x into a power y? That is a power x plus y equal to m into n is nothing but mn. Okay. Now, you observe, it is of which form? Observe this carefully. Imagine you imagine this as x. This x plus y as x. A power x equal to, you imagine this as b. This is of which form? A power x equal to b form. So from the definition of logarithm, it can be written as x equal to log b base a. So what this can be written as? This can be written as x plus y equal to log mn base a. I hope you are understanding. Okay, here what is x? You observe here, I considered log m base a as x. So in place of x, I'll write that only. Log m base a plus what is y? I considered log n base a as y. Log n base a equal to in place of x I written plus in place of y I written this equal to log mn base a. You observe here, we proved that result. Log mn base a equal to log m base a plus log n base a. Therefore, I'll conclude. What is this property? This property is log mn base a equal to log m base a plus log n base a. Okay. Fourth property. It is similar to third property. You observe m comma n are two positive real numbers, a greater than 0 and a not equal to 1. Then log m by n base a. Third property is what? Log mn base a. What is fourth property? Log m by n base a. Log m by n base a is log m base a minus log n base a. We need to prove this result. To prove this result, I considered log m base a as x. Like earlier property only, I considered log m base a as x and log n base a as y. As per the definition, this can be written as a power x equal to m and a power y equal to n. To get this result, what I'll do? I'll consider a power x divided by a power y just to get the answer. What is a power x? A power x is m divided by what is a power y? A power y is n. So in laws of indices, we learn this formula. A power m divided by a power n. What is the formula in laws of indices? That is a power m minus n. Correct? So please observe here, a power x divided by a power y is what? A power x minus y equal to m divided by n. I hope you are understanding. Now if you observe this, it is of which form? A. You imagine this as x. A power x. You imagine this as b. This expression is of the form a power x equal to b. A power x equal to b. Whenever, from the definition we learned that whenever you see a power x equal to b, we can write x equal to log b base a from the definition of logarithm. So here what it can be written as? It can be written as x minus y equal to log m by n base a. I hope you are understanding. What is x? I considered log m base a as x. So in place of x, I'll write log m base a minus, in place of y, what I can write? I'll write log n base a equal to log m by n base a. You observe here, we proved this result. Log m by n base a can be written as log m base a minus log n base a. I'll conclude. Therefore, logarithm of m by n base a is what? This is nothing but log m base a minus log n base a. I hope you are understanding. Now, I quickly recall all the four properties that what we learned in this class. First property, log 1 base a. What is log 1 base a value? Log 1 base a value is 0. Here you need to remember one thing. This a is positive real number and this a cannot be equal to 1. Similarly, second property, log a base a. What is log a base a value? Log a base a value is 1. You need to remember that here a is a positive real number and a not equal to 1. And what is the third property we learned? We learned that log mn base a, this can be written as log m base a plus log n base a. Next, fourth property, log m by n base a, this can be written as log m base a minus log n base a. Total 9 properties are there. We did proofs of 4 properties now. In the next class, I'll do the proof of remaining 5 properties. You see this fifth property. What is the fifth property? Logarithm of a power m base b. Logarithm of a power m base b is m into log a base b. Here a and b are positive real numbers and we know that base cannot be equal to 1. Okay, so we'll see the proof of this result. To prove this result, you take log a base b as x. How we write this expression into exponent form? Base power this number equal to a. This is what we learned from the beginning of the chapter. B power x equal to a. Now, to get this result, I'll take whole power m on both sides. For example, you see 2 square equal to 4 is there. I can square this on both sides. 2 square whole square is 4 square. I can square like this. In the same way, here I'll take whole power m on both sides. B power x whole power m equal to a power m. Okay. Now, you see this is of the form a power m whole power n. So what this can be written as? B power xm equal to a power m. You observe this is of which form? A power x equal to b form. Try to understand. This is a. Imagine this as a. A power x. This is x. A power x equal to b form. Whenever you see a power x equal to b, what you can write? You can write that x equal to log b base a. So here what you can write? You can write that xm equal to logarithm of a power m base b. I hope you are understanding. Okay, xm is nothing but mx only na. Xm is nothing but mx. So first I'll write m into x. What is x? X is log a base b. We considered log a base b as x equal to logarithm of a power m base b. So this is one of the important result we use very frequently in calculus part. So what you proved finally? You proved that logarithm of a power m base b, this can be written as m into log a base b. I hope you understand this. Now we will see the proof of sixth property. You see the sixth property, a power log m base a is m. A power log m base a is m. First I'll prove this result. To prove this result, I'll take log m base a as x. You take log m. I'm taking log m base a as x. From the definition of logarithm, whenever you see a power x equal to b, you can write that x equal to log b base a. At the same time, whenever you see x equal to log b base a, then you can write a power x equal to b. So if I write this into exponent form, what I can write? Base power x. That means a power x equal to m. A power x equal to m. That is what we are learning from the beginning of this logarithm chapter. Now you see here a power x. What is x? I considered log m base a as x. So here in place of x, I'll write this. What is that? Log m base a equal to m. You can observe here, we proved the result. A power log m base a is m. So what we proved here? We proved that a power log m base a equal to m. It is very simple proof, but we use this property very frequently. For example, 3 power log 7 base 3. If you want to calculate this value, what is this value? By using this property, you can say its answer very easily. 3 power log 7 base 3. It is of this form, so answer is 7. Now we will see the proof of next property. Seventh property. Log a base b can be written as 1 divided by log b base a. This is also very useful result. See here, log a base b, here reciprocal is there, 1 divided by log b base a. Okay, so to prove this result, first I'll consider this log a base b as x. Let log a base b as x, and you take this as y. Log b base a as y. Okay, now exponent form. As we know from the definition of logarithm, whenever you see a power x equal to b, you can write that x equal to log b base a. At the same time, whenever you see x equal to log b base a, you can write a power x equal to b. So how we write this into exponent form? See this, b power x equal to a. Here what it can be written as? It can be written as a power y equal to b. So this is equation 1, this is equation 2. Okay, now what I'll do, you observe here b is there now. From this equation 2, in place of b, I can write a power y. So in place of b, I'll write a power y whole power x equal to a. What happened? In this equation 1, in place of b, I written a power y. So this we got from second equation. We used second equation in this. Okay, a power m whole power n, that is a power mn. A power y whole power x can be written as a power xy equal to a. A can be written as a power 1. You observe here, bases are equal, na? So powers are also equal. So what I can write from this? I can write that xy equal to 1. From this, what is x? X equal to 1 divided by y. So I'll conclude. Therefore, you see x. What is x? What is x? X is log a base b equal to 1 divided by y. What is y? What is y? Y is log b base a. Hence, we proved the result. Log a base b can be written as 1 divided by log b base a. Okay. See this 8th property. Logarithm of a power p base b power q equal to p by q into log a base b. Here a and b are positive real numbers. We know that base cannot be equal to 1. Okay. How we prove this? First, I'll take this expression as x. You take this expression as x and this expression as y. Log a base b as y. Okay. So, from the definition of logarithm, what this can be written as? This is base power x. What is base here? b power q whole power x. Base power x equal to a power p. This we learn from the definition of logarithm. If we see expression like this, it can be written in exponent form b power q whole power x equal to a power p. And this can be written as b power y equal to a. Okay, this is of which form? A power m whole power n. So here this is b power qx equal to a power p. You observe this. In this, what is a? A is b power y. So in this, in place of a, I can write b power y. In place of a, I can write b power y whole power p. Okay, so what you will get here? B power qx equal to, this is of the form a power m whole power n. So this is b power py. As bases are equal, powers are also will be equal. So what you will get here? Qx equal to py. So what is x from this? You take q to this side. What you will get? P by q into y. What is x? What is x? Look here. What is x? What is x? X is logarithm of a power p base b power q equal to p by q into, what is y? We considered log a base b as y. Log a base b. Y is log a base b. So finally what we proved? We proved that logarithm of a power p base b power q equal to p by q into log a base b. Till now in this chapter we learn the definition of logarithm and the proofs of 8 properties. Now this is the first problem in this logarithm chapter. We need to find the value of log 4 base root 2. What is the value of log 4 base root 2? First you take this log 4 base root 2 value as x. I need to find the value of x. How we write this into exponent form? It can be written in the form of a power x equal to b. That is, it can be written as root 2 whole power x equal to 4. Our intention is we want to find x value. You see here root 2 can be written as 2 power 1 by 2. 2 power 1 by 2 whole power x equal to 4. Here root 2 can be written as 2 power 1 by 2. It looks like a power m whole power n. What is the formula for a power m whole power n? A power mn. So 2 power 1 by 2 into x. 1 by 2 into x is nothing but x by 2 equal to 4. 4 can be written as 2 square. Yes, now you see bases are equal. So powers are also equal. What you can write here? You can write that x by 2 equal to 2. From this, what is x? You take 2 to this side. 2 into 2, 4. So what is x? Actually, we considered log 4 base root 2 as x. So what is the value of log 4 base root 2? We got that log 4 base root 2 value is 4. You see the second question. If log x base 81 equal to 3 by 2, then find x. First, I'll consider the given information. What is the given information? They given that log x base 81 equal to 3 by 2. From the definition of logarithm, whenever you see log b base a equal to x, what you can write? You can write that a power x equal to b. So how we can write this into exponent form? It can be written as 81 power 3 by 2 equal to x. From the definition of logarithm, we learned this. If I write this into exponent form, 81 power 3 by 2 equal to x. Actually what they are asking in the question? They are asking you to calculate x. Okay, here 81 can be written as 9 square. 9 square whole power 3 by 2. 2 will get cancelled equal to x. So what you got here? 9 cube. 9 cube equal to x. 9 cube means 9 into 9 into 9. 9 9s are 81. 81 9s are 729. So what is the value of x? X value is 729. Okay. You see this question. 3 power 2 minus log 4 base 3. 2 minus log 4 base 3 is in the power of 3. We know this result from the laws of indices. What is that? A power m minus n. A power m minus n can be written as a power m divided by a power n. So it is also of the form a power m minus n. So what this can be written as? A power m divided by 3 power log 4 base 3. Please try to understand. This is of the form a power m minus n. A power m minus n can be written as a power m divided by a power n. Okay. So here what is 3 square value? 3 square value is 9 divided by, you observe here 3 power log 4 base 3. We learned this property a power log m base a. What is the formula for a power log m base a? A power log m base a is m. So 3 power log 4 base 3, what is its value? 3 power log 4 base 3 value is 4. So what is the value of 3 power 2 minus log 4 base 3? Its value is 9 by 4. I hope you understand this class.